Okay, this is a demonstration of our heart-evoked potentials, which we have recorded today. And first I want to show you the raw EEG. This is an EEG about 5 minutes. If I can enlarge here, you can see this is nice R waves, T waves, P waves, and we are setting a trigger to 400 to catch all R waves and record every epoch after the start of an R wave. Yeah? The level I have put here, and now I can do an average on all. This is just to see that some R waves are with artifacts, and the blue ones, they are excluded. The red ones are counted. Here the same. And now I can see the averaged R wave. Here is 0, is a big R wave, a T wave. Here we have another P wave, like here. And this is the beginning of the next R wave. Now we add pulse oximetry here with the, I think it's this channel. First I show you the signal of the pulse oximetry alone. This is the pulse oximetry. It's an ongoing up and down on the, which is taken from the right ear. And if I average it, I find that here is 0, the R wave, that at about 157, sorry, you see up there on top you see 157 milliseconds after the R wave, we have uprising signal in the earlobe. That means the pulse wave has arrived after 170 milliseconds. Yeah. So now we are looking at maybe an EEG channel and average there, and we can see this is CZ. We have in the brain, if we average 337 R waves, we have over CZ, we have a negative deflected R wave, and we have downgoing, maybe T wave, or maybe the volume conduction. We will see it afterwards. And then we have an event-related potential called HEP is heart-evoked potential, which is about here, because the R wave and this deep deflection can be due to the T wave or can be due to the volume conduction when the heart wave arrives in the brain. To see this, we will additionally add the EEG. Yeah, I have to overgo this. And because EEG is much higher in the voltage, we cannot see the EEG clearly. We do normalizing, and now we have EEG together with the CZ potential. We can see that at the beginning of the T wave, we have here a negative deflection, like here also a negative deflection of the R wave on CZ. If I additionally add the pulse wave, then we have all three waves here, and we say plot normalize, and I can also, let's start all with 0, 1 second, plot normalize, yeah, and we do a grid on, yeah. Now we have here in red, we have the averaged ECG, yeah. In green we have the pulse wave, which comes about 170 or 50 milliseconds after the R wave, and the blue one is the EEG, where we can see that this might be between the end of the systole, which is arriving at the brain, that there is a real electrical signal. In this case it's above zero. Zero line is this one, which says this is the EEG, which is correlating to the heartbeat. What we can do now is to do all channels we have recorded. Just let me do this. I clear the screen, and now I will add all channels from FP1 to PZ. And we can see that the R wave is sometimes positive, sometimes it's negative. Yeah. The T wave mostly is seen in the EEG channels as negative, but some are also positive. And if I want to analyze on which part of the brain we have which curve, then we can go through, let me say, for instance, FP1 and FP1, FP2, so right and left frontal, and we can see we have here on the FP1, FP2, we have a negative R wave and a negative T wave, and this might be the real heart-evoked potential, because here we have starting again the next T wave. So we can go through every pair of channels. Maybe as last, I would like to show you from front to back. If we go for PZ, CZ, and FZ, it should be somewhere up here. F7. Where is FZ?
Number 9.
Here.
Yeah.
Now we have the three midline. Channels all have negative R waves and negative T waves, and this part is the so-called heart-evoked potential for the midline channels.